Good then, in case someone isn't able to make it, they could watch this later. Okay, and I would love to tackle any questions you have administratively. Okay, and then we'll talk about questions you have subject matter wise, and then sort of do chapter three. Chapter three is actually, I think, really quick once you see how it's just a slightly different perspective on something we've already done and felt comfortable with in the past. We're going to introduce chapter three in the context of, you remember chapter one? It was called ANOVA. Well, we're going to redo it, but phrase things just a hair differently now than we used to. Okay. So, any questions about administrative issues like tests or stuff? Okay, so let me just mention then the only one big deal, and that may prompt you guys to ask a question. Um, there's a test coming up. You should take it by noon. Be done by noon of Tuesday next week. Most of you, I hope, will over the weekend do your prep work, and then you'll take it sometime Monday. But over the weekend is absolutely fine. Okay. If you do take it Tuesday, that's okay. Just make sure that you get it done by Tuesday at noon. And never, ever, ever, especially with weather or power outages or bad internet, never wait until the last minute to start it because that puts, I don't know, pressure on you. If something goes down, people get panicky. It's not worth it. Just let me know if there's something that you need as a way of working around, okay? Working around sort of problems that you have. If your internet goes down during the test, don't panic. Just send me an email when you can. We'll figure it out. It's not that bad. Okay. So any questions administratively? Okay. How about from past material? Chapters up through chapters two, up through regression. Not seeing questions, I'll just remind you that there is a sample set of exam questions online now. And the answers, I'm pretty much done writing the answers, but I'm not going to make them available to you until Friday morning. And then Friday office hours would be a great opportunity to sort of ask me questions about, hey, hold on a second, you wrote this, but I had the following. Is that close? Is that not close? In what way is my answer not quite perfect? You can fine tune your understanding on Friday, take the test over the weekend if you want, or you could sort of study up over the weekend and come by office hours on Monday and get yourself adjusted, make sure that you sort of feel real comfortable before you take the test later on Monday. With this whole virtual thing, at least the exam doesn't have to be during a limited period of 50 minutes, but it will be only 50 minutes. You just choose the 50 that you want. Okay. So let's sort of share a screen with you guys and dive right in on new material. And as always, I really appreciate it when y'all let me know if you have a question as we're going. And yeah, just putting something in the chat is good, but literally just unmuting and yelling at me is probably more effective because in the chat, although it's wonderful, I don't often see it until maybe the time has passed. So just yell at me if need be. So in chapter three, I want to sort of introduce the concept of chapter three by telling you about my family. Okay, I've got four kids, a wife. I am myself part of the family. I mean, it's a thing. If we were to line up shortest to tallest, okay, it goes kid number three, then my wife, then kid number one, and then me, and then kid number four, then finally kid number two is the tallest. Okay, um, fine. You might be wondering what our heights are. I'm 5'8.5". Okay, could I tell you everyone's height compared to my height? that kid number 1 is an inch shorter than I am, that my wife is 2 inches shorter than I am, that kid number 3 is 3.5 inches shorter than I am. Could I tell you all of the heights of everyone in the family compared to my height? How about compared to the shortest kid? Could I tell you everyone's height compared to the shortest kid? Would the numbers differ? Yes, they would. Could I tell you everyone's height compared to the tallest child? Could I compare the heights to the average height across the whole group? There are a lot of different ways of measuring heights. Now, I guess I could go from 0, 58.5 inches is my height. I could also say, compared to 58.5 inches, how tall is each person? Or compared to the average height, how tall is each person? Those differing perspectives are all valid. In chapter 3, we're essentially diving in on, we sometimes have multiple explanatory variables, and across the multiple explanatory variables, we have a way of describing uh, our ANOVA models, or if you will, a regression model with multiple x's. A general linear model is what we're going to call that. Okay. So in general linear models, yeah, I'm not going to stress this too much, but basically, anytime you have a collection of coefficients times a variable value added up, okay, that's going to be the typical value of a response variable. Okay, that's a general linear model. The way I would phrase that for regression is if I have an intercept plus then a slope times then x. That would be a general linear model. ANOVA can also be thought of as a general linear model or part of a general linear model. Now, I brought a data set with me called Discrimination with Dummies. That's probably a poorly chosen title for the data set, but these variables here, there's the score on the job qualifications index, the individual handicap that the videotape shows, and then 4 separate columns for, does this videotape have an amputation in it? Values of 0, whenever it is not an amputee, a value of 1 when it is an amputee. For crutches, not an amputee. So the crutch variable has a value 0 whenever it's someone who does not have crutches, 1 if the person is shown with a crutch in the video. No apparent handicap has a value of 1, or 0, 1 if it is no handicap shown, 0 for all of the different handicap groups. If I were to fit a regression model with more than just one x, with multiple x's, and I'm going to go ahead and do that with analyze fit model. So just first off, the authors of our textbook literally wrote the textbook for use with a software package Minitab. Okay, they call it general linear model. Our software here calls it model, fit a generic model. Okay, so anytime our book says general linear model, you think analyze fit model. So let's go ahead and try that. Here's my model. Rather than a 1x being listed, I still have a y, but I could put in a collection of x's. I could put in, is this person with an amputation? Are they with crutches? Do they have a hearing loss displayed, or no apparent handicap? And I'm going to claim across those 4 conditions that completely describes every possibility. Although there are 5 different conditions, you're right. There's the wheelchair group. Okay, I don't need that because literally, if the value for amputee is 0, that means they're not an amputee. And if the value for none, that none variable is 0, they don't have no handicap. Well, they're not displayed with a handicap in the videotape. If the hearing value is always 0, if the crutch value is 0, If all four of those are zeros throughout, it means that's someone in a wheelchair in the videotape. Okay. If I tell you the first four values, amputee, non-hearing, and crutch, if those are zeros, you know that's someone in a wheelchair being shown. This is essentially then allowing me to compare the amputee group, okay, to the wheelchair group. Okay, so X variable down here, a collection of them. The Y variable upstairs, Y score, depends on this collection of X's. If I were to run this analysis, you can see, among other things, the output looks a little bit different. I'm going to regularly get in the habit of just getting rid of the small stuff that is not so helpful. And let's focus on what matters most. The output looks a little bit different, but we still have things like R squared, the square root of the mean square error, okay? We still have an analysis of variance, okay, for the model. Parameter estimates, I have an intercept and a collection of slopes. My claim is the intercept would be related to, it is exactly equal to the average score given when the person is in a wheelchair. And my claim is the amputee value for the slope is for a 1 unit increase in the variable amputee, how much does the slope change? So the only way we get an amputee of 1, the variable amputee going up by 1, is to go from a 0 to a 1. It means you're going from a wheelchair condition to an amputation. Okay? So let's go ahead and verify that that makes sense. I'm going to analyze the distribution. Actually, I'm going to go ahead and use the fit y by x, because that's something I can do. We know that from past classes. The score may be different across the handicap groups. Click OK. And I see in my output, yeah, the same sort of thing we had looked at previously. But if I were to display the means and standard deviations downstairs, I'm going to note, among other things, the wheelchair average, 5.34, is exactly equal to the intercept. And if I were to look at amputee, instead of 5.34, it is about a 0.9 lower. Notice the amputee is 4.4 instead of 5.3. It's about a 0.9 lower. It's 0.9 below the wheelchair average. Okay. I'm also going to notice, among other things, if I were to turn on the means slash ANOVA part of the procedure, I have an F ratio of 2.86. I here have an F ratio of 2.86. I've got the same p-value. I've got the same mean square between the handicap groups, mean square error. This ANOVA table here that we used to look at is now the same as this ANOVA table here that corresponds to a regression with a collection of variables that are either ones or zeros. Compared to the reference point of the wheelchair group, saying how much does each group differ from the wheelchair group is the same thing as saying, are all the groups the same on average? There's got to be a null hypothesis over here that corresponds to this null hypothesis in the ANOVA. That's really what we're doing today. Okay. So analyze, fit model inside of inside of JMP is the way to go. Your Y variable is gonna be quantitative. Turns out that if your Y variable is categorical, it will still do something reasonable, but that's beyond the scope of this class. That's SAT 418. Great class, by the way, but not what we're doing this term. We may touch on at the very end of this term something related to that logistic regression, but that's not a certainty. Okay. But the X variables that we have, they could be numbers, okay, quantitative. They could be just lists of categories, or we could have some of each. General linear models means a quantitative Y and some list of x's. Okay, so let's sort of get into the issue of the way we would parameterize our variables. And that's just the heart of the lab today. And again, let me remind you of compared to my height, each person in my family is a certain number of inches taller, and negative inches taller means shorter than me. But I could also have compared to the average height across everyone in the family, or I could have compared every height to the shortest person's height. The point of reference is mu. And alpha tells me how far above mu each individual value is. Rather than saying each group has its own separate group mean, we're now saying there is an overall average. Now, I'll put that within air quotes. By the way, air quotes. Look up the video of non-ironic use of air quotes. It's really worth it. So the average for each group, we're no longer going to say it's mu for that group. We're going to say compared to a reference point, how far above average are you? So each group is allowed to be a certain distance above the reference group. And the null hypothesis that we used to say all the mu's are the same, each group has the same mean. Now I'm going to say there's no effect of which group you are in on your average. So literally, if alpha for every group is 0, it means compared to the reference group, there is no difference. If the effects, these alphas, are always 0, all the groups, they are the same on average. So the effects is going to be a more beneficial way of describing, okay, a categorical variable. Certainly it's more beneficial than just saying there's separate means for the different groups, because now as we proceed into future chapters with additional x variables, we're going to be able to say what's the effect of being in this group on maybe the overall trend line. Does it raise the trend line, or is the trend line maybe lowered, or is it unaffected? Okay, so the effect alpha, either they're always 0, null hypothesis, or at least one of them is non-zero. Okay, so let's look at that. How would I pull that off? Well, in my general linear model, okay, I said we're going to compare to the wheelchair group. By default, I just chose wheelchair as the group to which I compare. Maybe you would prefer to compare to the no apparent handicap group. That's okay. We got you covered. That seems like a natural reference, doesn't it? Rather than alphabetically last, wheelchair last, let's compare each group to the no handicap situation. I'm going to go ahead and try this with analyze fit model yet again. And rather than saying, and recall can be your friend, rather than saying score depends on amputee, non-hearing, or crutch, I'm just going to go ahead and delete all of these terms inside the model statement. I'm going to say just what handicap is it? Score depends on the handicap. There you go. Score depends on the handicap. I'm going to click run. And if I were to show you that output, again, way too much output there, but score depends on the handicap. In the parameter estimates of portion of the output, we could see, oh, darn it, it's wheelchair group that's left out yet again. But hold on, the amputee number seems to have changed. Our earlier amputee output said amputee was a -9 compared to the wheelchair group. Now our intercept is changed, but the amputee group is 0.5 below whatever that intercept is. What the heck is that intercept? Okay, so this is what we will sometimes call a sum to zero parameterization. If you want to test the hypothesis that all the alphas are 0 maybe we could require that all of them sum up to 0. And so if one of the alphas is positive, another one must be correspondingly negative. By default, that's what JMP and most software packages will do. They use a sum to 0 parameterization. There are multiple different possible parameterizations, but sum to 0 is the most common you'll see. But you might want to read the documentation of the software package if it's not JMP, because literally they might be using a reference group parameterization rather than the sum to 0. That would be unfortunate. Okay, so sum to 0 parameterization. I'm going to claim the sum of these is 0. And what we have now is only 4 of them are displayed. But let me ask you, if I tell you the first 1, 2, 3, 4 alphas, and the 5 of them sum to 0, could you figure out the 5th? I mean, wouldn't you just take the sum of the first 4 and swap them the sign to get the last alpha? Yeah. So I'm gonna say under estimates, if I were saying, yeah, show me the expanded estimates, it's not going to show you just the first 4, but it's gonna show you the first 4 and then that last one as well. In JMP, we have this expanded parameter estimates. In Minitab, it does not. So you will see in the textbook a nice little section of here's how to find the last one. Well, inside JMP, most students just say, show me the last one. Just click the button, you get it for free. Okay, so my claim is negative 0.5 plus 0.99 minus 0.87 minus 0.02 subtracted from 0 would be equal to positive 0.41. You can check that yourself later. So these effects compared to the, what is this intercept? Well, if the sum of the effects must be 0, each effect must be then, algebraically, equal to the average. Each effect must be the average of that group compared to the average across all the groups. So this value for the intercept, if we do have this sum to 0 parameterization, the default reference, the default parameterization, this is the average across all of the data values. No, I just lied to you. I'm sorry. It's the average of the group averages. That's probably a cleaner way of stating that. It turns out algebraically, if you have each group with the same sample size, the average across all the data points will equal then the average of the group averages. But if I were to tell you those group averages, and I think I had those earlier displayed. Notice I have the averages here for 4.43, 0.59, 4.05, 4.90, 5.34. The average of those is the 4.93 mu hat, if you will, the intercept. But I can, if I want, give you that alternative parameterization. By default, JMP gives you this sum to 0 parameterization. If you say, I would like an indicator or dummy variable parameterization, it will choose one group to use as the left out reference group. My gut feeling is it's going to be, for JMP, the last group alphabetically, but the software has to have some algorithmic way of choosing a reference group. So let's go ahead and try that. Under estimates, if I say show me the indicator parameterization estimates downstairs at the bottom, I'm saying compared to the group that I leave out, which is the wheelchair group, how much do each of these groups differ? This is like that regression style that we used initially. with 4 dummy variables, one for each of the variables that is not wheelchair, and we're comparing to the wheelchair average. But if you want no apparent handicap to be your reference, that's easy to do. Let me show you how to pull that one off. In this handicap variable section, I could right click on it and say under column properties, I could choose value order. JMP will always choose the last value according to the value order here to be the reference group. And alphabetically, wheelchair is last. If I were to take wheelchair and move it down, okay, I can't. If I were to take none and move it down, none would then be my reference group. Let's compare each of the handicaps to the no apparent handicap group. If I click OK, you can't tell, but I have changed the order of how JMP views these variables, the values of this variable. Okay, if I were to analyze now under fit model, boom, recall is your friend. It just repopulates. Score depends on the handicap. Click OK, good to go. I have the same output as before, except for, even the same F ratio, always the same F ratio. But under parameter estimates, darn it, it is still comparing to the average. We need to turn on the indicator parameterization. So under estimates, indicator parameterization. Now we see, the no apparent handicap group is the group that was left out. Compared to the average of the no apparent handicap group, 4.9, each group is different than that average of that group. Let me look over here. Look, no apparent handicap, 4.9. That is my now reference. I'm referring to or comparing to no apparent handicap. Okay, so I've talked for a long time. Maybe what I want to do is pause and say, y'all got questions?
Yeah. So that last thing that you were just doing, why would you ever want to do that compared to a 0?
Why would you ever want a particular group to be the reference group? Is that your question, Harrison?
Yeah, pretty much. Why? Like, what is the benefit of using a reference group like that?
Well, I'm not going to say there's a strong benefit from my point of view as a statistician, but I will say if I want to know how different the amputee group is from the no parent handicap group, I can tell you it's estimated to be 0.47 below. I get that for free. And I can even tell you whether it's statistically significantly below the no apparent handicap group. So if you do have a natural reference to which you would compare, and I think in the lab I asked you to tackle that with the antibiotics data set for part of the lab, maybe you have a favorite antibiotic and its binding percentage is what you want to compare the other antibiotics to. I guess in drug studies on medicines that relate to heart disease, we presumably should compare to not no medicine at all, because someone who has heart disease should be taking a medicine. You don't want a control group that's no medicine because those people drop like flies. What you want to do is you want to compare them to the current state of the art treatment that we know is at least minimally going to be prescribed, which is a daily aspirin at a 71 milligram or 73 milligram dosage. So, like, let's compare all these new heart medicines to suppose someone's just taking aspirin. Does that address your question?
Yeah, totally. Thank you.
And it really does depend on the context. I mean, I would think in crops, it's sort of going to come up pretty naturally because there's the way you would normally treat this particular crop. And then there's each of the alternative treatments you might want to compare. The reference group parameterization with that particular, the standard method as that reference group is a little bit cleaner, but you could get from either style of output everything you absolutely need. Someone else want to follow up on that?
Not on that. I had a different question.
Sure, different questions are still fine.
Okay, so I guess I'm trying to wrap my head around why using like a linear model works for like a categorical variable in this case. Is it because they're means and that's why the fit is okay? Like I just have a hard time understanding why the categorical variable would be linear at all.
Okay, so the categorical variable handicap literally is 5 different categories. But if I choose to view it as 4 separate quantitative variables that each have the value of 0 or 1, then I could view it as a regression-like model. Literally, there is an intercept plus the associated slope for if you're in that group. So if your value for the variable, well, let's go back to the, shoot, did I have that line around? Yeah, that might be it. No, that is not it. Darn it. That's it. Yes. Okay, so in this particular way of looking at things, we had 4 dummy variables and amputee, none, hearing, and crutch. If you're in the amputee group, your value for that one column is a 1. And as you go from the wheelchair group to the amputee group, you're increasing the variable of the amputee group by 1. The slope itself means how much does y change on average when this x changes upwards by 1 unit. The only way that x could change upwards by 1 unit is going from the wheelchair group to the amputee group. So the slopes for these dummy variables, or indicator variables, if you will, correspond to differences between means. So I think that answers your question, but maybe I didn't understand it. Rephrase it if you
understand, yeah.
want.
Okay, I will. I understand. So that makes sense from like a technical point of view, how technically we're able to convert this categorical variable into a value, like a quantitative value that then we can plot on a linear curve. But I guess like, what is the, I guess, reason for, because to me, I don't think of handicaps as things that are from 0 to a number. I think of them as kind of independent things that don't increase with a slope. Whereas
Correct.
some things like the housing price example, that's very clearly there's a relationship. And as it's like this continuous value. I guess the linearity of this is like, is there like a way that you can explain why like it makes sense to have a 1 increase be like, yeah, I guess, yeah. Does that kind of make sense? I don't know.
Yes. So I'll sort of say your answer of technically that's how we did it. That is my explanation. We need the ability to technically get it done, to compare 2 groups. And literally the way that we do that inside the internals of ANOVA is via these dummy variables. Literally, that's how it was done inside the. Okay, so for those of you who've taken matrix algebra, I could walk you through an explanation of this. If you really want to do that, there's stat 534 where this would be exactly covered. But yeah, literally, it is just a trick. And there is not really a 2-unit increase in the variable amputee. It's only ever taking a value of 0 or 1. So we're only comparing 2 different levels of it ever. So what was a slope is only really a difference between 2 distinct levels. So algebraically, matrix algebra wise, it's a trick. And yeah, we're only using it in that regard. But the nice thing that we have now is the concept of considering a collection of alphas. We could have all the alphas summing to 0, and I have not told you how the software gets that job done. But it is via something like what we've just done with the last group with a value of 0 always, and each of the other groups being a column with either ones or zeros, 1 if you're in that group, 0 if you're not.
Okay,
Again,
that
that's
last part
yeah.
answered my question. We're
Yeah.
doing the line to see if the alphas are the same. That's not the same as comparing all the alphas to each other. And that's, I think, where I was getting confused. That's really helpful. Thank you.
Yeah, I think what it boils down to is we always feel guilty in every single class we teach below the PhD level, because there's always some subtler or deeper level of beauty, okay? And we don't present it. We just show you things like your third or second grade teacher did when he said, "Oh, there's no such thing as a negative number. If Bob has 3 apples, Jenny can't take 5 apples away from Bob. There's no such thing as the ability to do that." And then later, by grade 7, we all learned, "Oh, my teacher lied to me." Yeah, sorry. We're just explaining a lot of stuff via analogy. Okay. Another question, maybe. Okay, so here's where we're going to sort of say, you go do it. On the Canvas, there should already be 2 data sets. One should be dioecious trees, and the other is the antibiotics. It's in the lab 4B section. And lab 4B walks you through this exact concept of this 2 different ways of parameterizing things: the sum to 0 parameterization or the reference group parameterization. And in 2 different contexts, you'll grapple with that, but it boils down to just, to what number do we want to compare? I naturally compare people's heights to my height, but my kid, who's the shortest kid in the family, would compare everyone's height to her height. Both are reasonable. In that same sense, you have to have a reference point, and there are some natural reference points to choose. The lab will walk you through those. So let's sort of stop recording and turn you loose on the lab. So record, stop.